And then what other word? Into that.
Nope. All right, we're on page 295. On page 295, we are going to talk about what an inscribed angle is. So you know what a central angle is. Where do you think the vertex is going to be for an inscribed angle? So it's not going to be inside the circle. It's going to be on the circle. So the vertex is on the circle, and then the sides of the angle are intercepting an arc. Oh, yeah. That was good, right? Yeah. This guy, a little wonky. Okay. Now, here is the important thing. The inscribed angle is going to be half of the arc measure. Okay, so if this arc is 80 degrees, then our inscribed angle would be 40. Alexa, you made a face.
Yeah, like, well, didn't we just do like if it's 40 degrees and this is 40 degrees?
Okay, so how would that picture be different? When are they the same? Where does the vertex need to be when they're the same? At the center. So if we had this 80 degrees, then this is 80 degrees. So if the vertex is at the center, the arc and angle are the same degree measure. If the vertex is on the circle, the arc is double the angle, or the angle is half the arc. Everyone think about it. This is such a weird schedule. Like, I'm really confused that I'm seeing you after I ate. You know what I mean?
Yes. Math on
All right, so down here under theorem 1010, I would like you to draw this picture for us to do this example. Okay. Okay, so if we have this picture, how might we solve for x? There's two different things we could do. What's one of them? Double what? Okay, so you're saying we could say 4x plus 2 equals 96. Okay, what would be the other way we could do it? Okay, what's half of 96? Okay, so we could solve one of these two equations. Should we get the same answer no matter what? Yes, Mrs. Sullivan. Okay, so we can either double the angle to equal the arc. That's what we did here. Or we can half the arc to equal the angle. That's what we did here. Either way, when we solve these, please pick one to solve. Figure out what x is. Yep. What? 23.5?
Yeah.
Do you remember when you first learned how to solve equations and you were like, man, this is gonna be hard. Now we just like do it without even thinking very hard. It's pretty
Yeah.
sweet.
Look how far we've come in, what, 7 years?
You think you were solving equations in first grade?
I mean, we were doing. I do not
plus and
remember
minus.
kindergarten first or second.
I think that maybe in middle grades, you had something like x plus 2 equals 5, and you had to figure that out. Like, I feel like,
I mainly remember teachers, less about.
yeah.
When it happened. I remember learning it.
I remember I was so excited.
Okay. All right, let's go ahead and turn to the next page. Okay. So I'm gonna zoom in on this picture. Notice how A, D, B, and A, C, B, what do they have in common?
From the X.
So they're eating the same arc. Do you see that? Okay, so if AB is a certain measure, let's just say it's 90 degrees, then we know angle D would have to be 45 and angle C would have to be 45 because we would cut that in half, right? So what this theorem is saying is, hey, if you have two angles that are inscribed, right? We have vertex on the circle. If they're intercepting the same arc, then they're going to have the same measure. Whether we know the measure or not, we know those angles are going to be the same. Yes. So let me give you an example of a situation where that could occur. I'm going to draw a circle. You guys are going to get really good at drawing circles. Just stamp it.
Like, I should like a pencil, like, what the give.
Mm-hmm.
Like a spaghetti.
What? Did you say spaghetti fork?
No, it's like twirl spaghetti.
Isn't that just a fork?
No, like.
The spaghetti fork is actually a real invention. It's weird. It's like a fork where you press down, it like spins it on its own.
But it's big circle. So like.
I know, it's fine. It'll. I know. They like this?
No, it like spins.
Dude, like a lecture.
Spinning spaghetti.
This is spinning.
Oh.
It's just.
How lazy do you have to be?
Yeah, I feel like it'd be a big waste of money. Because like, you just spoil your own.
That guy right here?
Yeah.
Oh my gosh.
It twirls the spaghetti for you.
Oh my
All right, Brayden, you're really missing out here today. All right. Okay, so do you have this picture?
I did.
Okay, so our code word is spinning spaghetti fork.
It's like as useful as a cereal bowl with a straw in it.
I didn't jump myself.
No, it has a straw so that you don't have to like pick the bowl up. Just drink the milk with a straw.
Oh, yeah, I have that.
How do you know?
I'm not a cereal eater.
I have need to.
Okay, so what are we gonna do with this? Okay, we know that x better equal 2x minus 3. Pretty lame.
Yeah, a weird way you could tell the yours is minus 2x to x.
I think we should cancel track today.
It is beautiful outside. Oh, you guys are gonna have such a wonderful practice.
If it's windy again, I swear that.
I don't think it is.
Like, it just like flooded in the air yesterday.
No, why should it?
I didn't even realize it was supposed to be so windy yesterday.
They were.
It's pretty bad after school. All right, let's talk about some vocabulary words. Okay. If we have a polygon inside of our circle where all the corners of our polygon lie on the circle, then we call that an inscribed polygon because the polygon is inside of our circle, but on the edge, okay? We also call the circle to the polygon is it circumscribes circle because it's fitting that outside, okay?
If we know if it's a perfect shape, then doesn't that mean all the parts are the same shape?
And by perfect shape, do you mean regular?
Like regular shape,
Yes.
like equilateral, triangle,
Yeah.
normal square.
Yeah. Okay. All right, now I want you to come to this picture right here. Okay. What do you know about AC? It is a diameter. And if AC is a diameter, what does it mean about this arc that I have highlighted in yellow?
180.
It is 180. So if we have a semicircle, we know that the arc is 180. Well, if I draw an inscribed angle, what must that mean about the angle? It is a 90-degree angle.
So like a normal.
Too much stuff to remember.
How is that too much to remember?
Well, there's also the polygon.
If there's a line going through the middle and you see a thing connecting to both ends, it's a right.
Okay, so in the notes portion, I want you to draw this awesome picture.
Oh.
Is that a compass? Compass is-
Well, it would help us to know what that angle would be to get arc AB. So let me ask you this question. Do we know what this angle measure is right here? We know that that's a 90-degree angle because it's intercepting a semicircle. So if that's 90 and this guy's 25, what is this right here? So you're saying that this is 65 degrees. Well, if that's 65 degrees, then the measure of arc AB would be no. 130, we would double it. Okay, my triangle might not be drawn right, but it's fine.
It makes me feel bad.
I'm sorry. Okay. Last thing. Fun fact. If we inscribe a quadrilateral, then the opposite angles are going to be supplementary. So quadrilateral, how many sides? Okay, so our diagonal angles are going to be supplementary. So D and F are supplementary. E and G are supplementary. That's going to happen every time all four corners lie on the circle inside. Okay. So we're going to do an example here. We're going to give H, I, J, K. All right, so here's the picture that you're drawing. Okay, so how do we find X? What is going to be true about this angle that is 78 degrees and this angle that is X?
Equal to 180.
They are supplementary. So X plus 78 equals 180.
How is I and K supposed to equal each other?
They don't equal each other. X is 102. What is true about our opposite angles in an inscribed quadrilateral? They aren't equal, they are supplementary. So we are going to take 3y plus 30 plus 2y plus 10, and that equals 180. Some of you are really quick to assume. Okay. Those are the things that we need to know. So in your folder, I would like you to turn to the 10.4 worksheet, which I can't remember what page it is. So I will work off of that one, page 8 and 9. Page 8 and 9. Oh my gosh.